Hello everyone, my name is Mary Deborah with metric number 75573. I'm from Group Perseverance and our group consists of 5 students including myself. The first student is Ashley Laja, anak Alexander, and then Damien David, Gary anak Joseph, and Nathalia Ganette Paran. Next is the table of content. For the project description, based on the current design of NIPA SEP transportation added on sensor on the boat, selective sensor has to be applied on the boat. It's used as a guide and to assist boat to work autonomously. Next, the objective of the project. First is to implement the design solution by the using theory of engineering design and the robotic and automation application. Then, to determine the selective sensor as to achieve the requirement based on the society, environmental and sustainability related issues. Next, for the sketching of sensor location. As we can see from the slide, there are 2 camera sensors which is located at the front of the boat and the ultrasonic liquid level sensor which located at the top of the basin.
Now I will be presenting the specification of the camera sensor. There are different types of proximity sensors like LiDAR, radar, ultrasonic sensor, camera sensor, and infrared sensor. The selected proximity sensor is camera sensor that will assist the boat for maneuvering autonomously. The camera will be used for displacement measurement for obstacle avoidance. Optical flow is an image processing algorithm that helps calculate the velocities of objects between 2 consecutive images. Moving on to the sensor performance. Firstly, sensitivity. The camera sensitivity refers to its ability to respond and capture light into the sensor. The selected camera sensor shall have high sensitivity for it to work under low light condition. Next, linearity. The importance of linearity of camera sensor is for accurate displacement and velocity calculation. The images captured by the camera is linear to the light intensity of the environment. However, nonlinearity comes into play between voltage output for speed control versus the displacement. The range and span of the camera sensor includes the field view of the camera, resolution of the camera, and ISO, or sensitivity of camera sensor to light at different intensity.
Reliability. A camera sensor must be somewhat resistant to various conditions such as humidity, dust, shock, and many others in order to increase reliability. For this project, a suitable camera sensor must be selected and thorough installation must be carried out. Accuracy and precision. The accuracy and precision of camera sensor can be improved by increasing frame per second, improve resolution using stereo camera or combined with other sensors like IR sensor. Repeatability. The camera sensor must be able to reproduce the output signal exactly when the same measured input is applied under the same environmental condition. In return, with consistent image output, the microprocessor can produce consistent velocity readings. Last but not least, the price. The price of camera sensor differs according to its specification, which may range from 10 ringgit Malaysia to 1000 ringgit of Malaysia. For example, Arduino camera module is 9 ringgit and 80 cents, while Raspberry Pi stereo camera is 960 ringgit in the market.
Next, we attach an ultrasonic sensors which utilize ultrasonic wave of high frequency to measure the levels of liquid in PASEP. It is positioned at the top of the tank and directed downwards. And this sensor or transmitter emits wave that bounce off the medium and calculates the time taken for the echo to return to the sensor. Hence, the volume of the PASEP in the tank is obtained.
For the sensor performance, the sensitivity of the sensor is high sensitive that can detect small changes in liquid level. They can detect a level as low as few millimeters. The sensors also offer excellent linearity, meaning that the output of sensor is directly proportional to the liquid level. The sensor had a wide range and span, meaning that they can measure liquid level in tanks or vessels of varying sizes. They can measure level from few millimeters to several meters. The response time is very fast response time, typically measuring the liquid level within seconds. This makes them suitable for applications that require real-time monitoring and control. The reliability is also high, that can operate in harsh environments such as extreme temperature, high pressure, and corrosive liquids, which very suitable for our design. The accuracy also is very high, typically within a few millimeters. This makes it really suitable application require precise measurement and control of liquid level. Ultrasonic sensors also offer excellent precision and repeatability, meaning that they provide consistent and accurate readings over time.
Signal conditioning. The ultrasonic level gauge is a digital level gauge controlled by a microprocessor. The transducers produce analog signal in response to a physical stimulus. These analog signals are continuous and vary over time. To make sure these signals useful for further processing or analysis, they need to be converted to digital signals using an analog to digital converter (ADC). Signal conditioning helps to prepare the analog signal for conversion to digital by modifying it in some way. The analog signal may need to be filtered, amplified, or otherwise modified before it can be accurately digitized. Once the analog signal has been conditioned, it can be digitized using an ADC. The ADC samples the analog signal at a high frequency and converts each sample into a digital value. The digital signal can be processed, analyzed, or transmitted using digital signal processing technique.
As a conclusion, we have discussed the suitability and specifications of the sensors for our robot. The implementation of camera and ultrasonic sensor will assist the robot to work autonomously. That's all from our group. Thank you.